Dear friends, in our Amazon tutorial, we are going to see today Route 53. Now, what is Route 53? Amazon Route 53 is a domain resolver or a DNS resolver, which is a highly available and scalable domain name system web service. You can use Route 53 to perform three main functions in any combination like domain registration, DNS routing, the health checking. If you choose to use Route 53 for all three functions, perform the steps in this order. Like you have to first register your domain. You can register your domain either with Amazon Route 53 or you can even use an external domain like a Godaddy domain. Route internal traffic or internet traffic to the resources for your domain. Check the health of your resources. So you can have a health check. Amazon Route 53 health check is a public service with which you can health check either your internal resources or even the external resources. So let us start with Route 53. You have DNS management, you have traffic management, you have availability monitoring, and of course you have the domain registration. If you don't have a public domain, start creating a domain, register a domain with Amazon Route 53. You can compare the cost with the external domains and you will find it like Route 53 is much affordable. So let me start with the DNS management. Step number 1, you have to create a hosted zone. Now you have two choices here. Either you can create a hosted zone as a public hosted zone if you have or if you want to have a domain with internet visibility, or you can have a private hosted zone where you will have the domain only visible within the VPC. A private hosted zone determines how traffic is routed within Amazon VPC. Your resources are not accessible outside VPC. You can use any domain name, okay? Even it is not going to conflict with the public domain names. So for user acceptance testing and all, you can create a domain as a private domain which closely resembles your public domain. That's a good advantage Amazon that gives with Route 53, having a public domain as well as the private domain having the same name. So if you try to access the domain from a internet visible browser, public domain name will be used and you will get the responses from the internet visible machines. Similarly, if you try to access it from within Amazon's VPC resources, you will get a response from the private hosted domain. Let me first create a public hosted domain. I have a domain in Godaddy. Okay, so the domain name is cloudvarsity.co.in. So let me have my domain, and if you can see this is Godaddy. And currently my domain uses Godaddy's name servers. So what I should be doing, I go to Route 53, create a hosted zone exactly in the same name as the Godaddy registered domain name. Even if you create it in uppercase letters, it will be automatically converted to the lowercase when the domain is created or when the hosted zone is created. A hosted zone acts like a container, okay, that holds information about how you want to route the traffic for this domain. So let me create it as a public hosted zone. Create. When you create a hosted zone, you will have two record sets created by default. One will be an NS or name server record set, and another one start of authority record set. These two are the default record sets which you cannot delete. They will be automatically deleted when you delete the hosted zone. So take the NS record sets and copy these NS records. Okay, you are not supposed to make it visible in a public domain. Okay, so if you are putting in some document or somewhere, you have to just mask it with something. Okay, fine. So let me have a copy of it somewhere. Let it be there. Let me take each one go to Godaddy, replace Godaddy's domain names with my custom Route53 domain names. Make room for 4 entries. Take the second one, paste it. Take the third one, paste it. Take the fourth one, and paste it. You need not copy the last dot. Okay, paste it without that dot. Save. It will take some time for these changes to get affected. So these are the ones, but don't think it is going to be affected immediately. It will take some time. Okay, let it be there. Come back to Route53. So we did the first part of it. Now what you can do, you can create a record set to point to this particular domain. So you can create Apex records, or you can have the primary domain itself. For example, you can create a www.cloudwatercity.co.in pointing to an IPv4 address of an EC2 instance. For example, let me create a EC2 instance quickly. Let me create an EC2 instance from the launch template. So I have the user data script in this template, which installs the Apache web servers and puts a sample one-liner website. So come down. I have bin bash, install Apache, start Apache, mark Apache always on, and welcome to EC2 Oregon region. That's one-liner website and the home page index.html. So let me launch this. A T2.micro instance would have been launched by now. Let me go to instances. So let me have some USA web server as a tag name. Must be running by now. Yes, it's already running. Copy the public IP. Let me connect it via PuTTY. Connect using the default user EC2-user. Fine, we are connected. Okay, so let me just check whether the website is running. It's good, it's running. So let me check it whether port 80 is visible to the browser. Yes, it's visible. So come back to Route53. You created a hosted zone with the name cloudwatercity.co.in as a public hosted zone, and you are going to create a www record set. So www.cloudwatercity.co.in pointing to this IP. So let me make the TTL little low. Okay, 10 seconds, it's fine. So a routing policy, simple routing. Simple routing means apple to apple. If it is www.cloudvarsity.co.in, if anybody presents this this domain name in a browser, they should get a response from this EC2 instance website. We got it created. So let me see whether this is good. Okay, but don't think immediately it is going to be available. Let me try it. So www.cloudvarsity.co.in. See, welcome to EC2 Oregon region, which is coming from this EC2 instance 34.213.138.110 public IP. Again, don't show this public IP explicitly, without any masking. If you are going to put it in a document or somewhere. Amazon Route53 has a lot of routing policies like weighted, latency, failover, geolocation, multi-value answer. For this tutorial, let me show you the latency-based routing. Latency-based routing responds to queries based on the Amazon regions. So what you can do, if you have an application which a large user base distributed across various places within a US, instead of making everyone go to a single location, you can distribute your application to be running in multiple regions, and you can have a latency based record set created so that the people in and around of that region quickly connects to the web server running in that particular region. For example, this one is running in Oregon. See here, this EC2 instance is running in Oregon. So if I create a latency record set, anybody in and around of Oregon, if they present www.cloudvarsity.co.in in a browser, they should be going to the immediately available with minimum latency web server. So US West 2 has been automatically taken here because this virtual machine is running in Oregon. And you can give some ID. So let me say USA lat 1. Okay. Save record set. So I changed the symbol record set to a latency based record set like this. What I'm going to do now, I'm going to create one more instance in Mumbai. So let me go to Mumbai. Let me use a launch template. You can see the user data script, Apache, you see me an India server. That's the wording in the index.html. Launch instance from template. So we have another instance running in Mumbai. Okay, good. We got the public IP. Let us connect it via PuTTY. It must be booted by now. Not it. Okay, let me try once again. Almost. Restart. Okay, booted. Curl localhost Apache must be running by now. Yes. You see me an India server. Working good. Let me check it in a browser. You see me an India server. Working good. So let me come to Route 53. Now create one more record set. The same www. But this time I'm going to paste the IP address of the India server. That is the one which is running in Mumbai. As a latency, Mumbai AP South 1 has been automatically taken. India lat 1. Create. So we got a www record set for USA. We got another www cloud over city record.in for pointing to USA, as well as another one pointing to India. You can see here this one pointing to the Oregon site, another one pointing to the Mumbai one. Let me try it out in PuTTY itself. This machine running in Oregon, this machine running in Mumbai. You can see it here. So curl www cloudwatercity.co.in. I'm going to the Oregon region server. If I do it in Mumbai, you are seeing me in India. Wow, you see me in an India server. So latency is working. Latency based transfer is working. If I try it in a US based machine, it is going to, or Oregon based machine, it is going to the Oregon web server, because I'm trying it directly from a machine running in Oregon. And if I try to run it from a machine running in Mumbai, it is going to the Mumbai server. Let me try it from the browser. Let me just refresh the screen. It's going to India server because I'm in India. I'm trying it from India. So it is going to the India server. Earlier, you have seen it earlier. It was going to the Oregon one. So from the browser also it is working good, the latency based routing. So that was a quick tutorial of demonstrating Route 53 hosted zone creation, record set creation. In our real class, like in the solution architect certification course, we go beyond and we demonstrate to you how can you create a geographically distributed weight balanced application with failover. That means if all the web servers running in Oregon fails, automatically this will take you to the next one available as a failover, that is to Mumbai. Okay, in this case. So I'm not going to show that now here. So that's for a real course. Thank you very much. Thanks for listening.